11-2. So as we take a look at this thing, it says determine the lateral area and surface area for the following. We're going to talk about what those two words actually mean. But first, I would like you to describe this particular object that you have there. I think it kind of looks like those little things you used to put on your pencils. If you had a hole in it, right? Those little triangular things. But what would it be? Is it a, first off, I would say, is it a cylinder, cone, pyramid, prism, sphere? What are we looking at here? It's definitely a prism because there is a top and a bottom that are the same, right? It happens to be a triangle, right? So how would we change triangle to an adjective then? Triangular. So this is a triangular prism. You could actually get more specific in this case if you wanted to. Some people want to call it a right triangular prism, but the word right is going to mean something else in this chapter, which is why I don't start using it here. So let's just call it a triangular prism. Lateral area. Well, yesterday, didn't we talk about lateral edges? Lateral edges were the ones that went up from the base, correct? So if we had to just kind of outline the lateral edges, those pretty much would be it, correct? Do you agree that there are actually faces there then? That in the back, if I were to sneak a peek around the corner here, what object would be right there? What shape? A rectangle. What if I'm staring right at the front here? What am I looking at? And what if I took a peek around the right side? I would see a rectangle. So let's go ahead. What I'm going to suggest you do, and this has helped a lot of people in the past, and I don't know why that one just got enormous, but maybe draw yours approximately the same size. But let's get these out of here. Let's just talk about this front one for now. Do we know the dimensions of this front one? We know how tall it is, right? That's a lateral face because it's going up. How tall is that one? It is 7. Okay, so do we know how much, say, the top of it is, though? Do we know that measurement? Not right now, but we'll figure that out in a second. So let's go ahead and go to another face. So let's say we were going to take a look at this one that was around this left-hand corner. Do we know how tall that one is? That one's 7 tall. And do we know how, I guess you could say, wide that particular one is? It's 4. Yeah, it's sitting right on top there, right? And we only have one more to take a look at then, and when we have to go finish the other one. And that's if you took the peek around kind of the right side. How tall is that one? 7. And how, I guess we'll use the word wide? 3. So do you agree that the one I did in blue and the one I did in green are two that we could find the area of right now? Because those are rectangles. The problem is that we don't know the one that I've done pretty much in red. That's because when we did that one, we were missing a measurement. Has anybody kind of looked at the problem and figured out how we could get how wide that one is? Yes? Yeah, if you take a look at the base, it is a right triangle, and this is 3, and that is 4. Agreed? Can we use Pythagorean theorem to go and find that other side? Yeah, it's a right triangle. We can do that. Does anybody happen to remember that is a triple? It is 3, 4, 5, exactly. If you had forgotten, you would do 3 squared plus 4 squared equals, we'll call it, I guess, x for now. X squared, right? You could do that. I'm hoping you start learning the triples because that's a lot less work, right? Doing the triple. So what do we got? 9, 16, x squared, 25 equals x squared. You take the square root, and we get 5, right? But much quicker just to know that it's 5. But don't get lost in the problem. Why did I go figure? Is 5 the answer to this entire problem? No, 5 is basically right there, agreed? And so if I were to take these 3 rectangles that I found, do you agree those are the faces that are going up? And it's all of them, correct? So that would be your lateral area. So how about this one right here? The one that I made the smallest, which happens to be the biggest area, 35, right? It would be square units, right? This one here in the middle that I did in green is 28. And the one I did in blue, which is 21. Now, not those numbers separately add up to be necessarily the lateral. What you have to do, like I said, is add them up. So we got 35, 28, 21. What's the lateral area? Right here for this area. And I will always abbreviate that LA, lateral area. Not Los Angeles, no. We got 35, 28, and 21. What is it? You tell me. Is it 840? And square units. That says lateral area. Are those all the faces that are on the surface of this object? Is it a lot of them? In fact, it's most of it, right? What have I not taken into consideration yet Yeah, the triangles, aren't they on the surface? If that object was sitting right here in front of me physically, there would still be a top and a bottom to that thing, right? And so what we have to do, but the nice thing here is the one on top and the one on the bottom. Can you tell me what's the one on the top and the one on the bottom? They're the same. So if I could find the area of just one of them, I can just double that, and that's the area of those bases. Now, I was very nice here. Should we use perimeter times apothem divided by 2 on this one? No. Let's just do base times height divided by 2. But remember, for a triangle, the base and height have to hit each other at a... Do we have one? Oh, how about that? We do. So we take 3 times 4, because those are the two that hit at a right angle. So 3 times 4 divided by 2 is... 6 is the area of how many of the triangles? Just one of them, right? And how many do I have? So let's take that times 2. And then I wrote the answer. Take this times 2, which is 12 square units. So is 12 square units the total surface area of the triangles? But is it the total surface area of this triangular prism? No, 12 is just the bases. What do I have to do with 12 to get the total surface area? Add it to the 84 we already knew, right? And what do you get if you take 84? And for surface area, I'll just use SA, or sometimes I will use TA for total area. It depends on what word they use. Those are interchangeable. Sometimes I stay away from that one because it sometimes gets a giggle. But 84 and 12, when added together, 96. Now, this I believe to be the longer method of finding this answer. But I'm going to tell you right now, if this works for you, this will work all chapter. Obviously, as the base gets a little bigger, say a pentagon or a hexagon, is this going to get to be a little bit more time? Yes, but it will work. The rest of this chapter, I'm going to show you formulas that will speed things up. But if you are not good with the formulas, if you're more visual and you want to see the faces, I have no problem with you doing it this way, all chapter. Okay. The only time where you might run into trouble is the sphere and the visualization of the cylinder and cone. That would be about it. So any questions? How basically all I did is I took all the faces, found the areas, and then added up the ones I needed. Pretty straightforward, right? Okay. Well, that's probably the hardest problem for today. So let's go ahead and try. Well, for some of you that'll be the hardest. For some of you, actually drawing the objects will be the hardest. Now, do not stare at the dots too long or you may get dizzy, which means some of you will do that now. This is the isometric dot paper. It's called isometric because, like I told you earlier before we started recording, all of these measurements, no matter which way I go, to each dot is the exact same measurement. If you were to use square dot paper, 6 would look 10 times bigger than 2, and it would just be distorted, where this should actually be fairly accurate. So here's how I would use it, not to make stars like I did here. And in fact, I think on your dot paper, they're each 1 centimeter long, I think is what they are in that case. So here's how I would do it. Start somewhere in the middle. I'd say kind of, and I go a little bit to the left because I normally make mine out to the right because I'm right-handed. That's how I do it. And we're going to make it 1 unit high. I always start with how high it is, so there you go, 1 unit high. And you can pick where, notice I do start a little bit to the left and down because I go up and to the right when I draw. If you know you go up and to the left, well then start over to the right. This is just how I draw. It has to be 2 units wide and 3 units long. That's where you have to decide how you want to kind of draw that. But normally what I'll do is from here then I'll go 1, 2, 3 off on a diagonal. What the isometric dot paper does is gives you the diagonals that some people can't see. All right? So you got 1 right here, I got 3 right there, and then I'll go 2 this way. Have I taken care of basically all 3 measurements then? I had 1 by 3 by 2. Do you see how they're all in there? I always start with height. That's just the way I do it. You don't have to. Okay? Now to finish it off, what I'll do is I'll copy that 3. 1, 2, 3. Do you see how I copied 3 going that way? And I'm going to copy. Is everybody, am I going too fast or is this okay? Or am I just in the way for you? Sorry. So if I copied the 3, what am I probably going to copy next? The 2, 1, 2. Everybody with me so far? Copy the 1, copy the 1. Well, obviously I'm not done. Can anybody help me finish this one? Yes. You can come up if you want, yes. Or just tell me, whatever you want to do. Because some people, again, struggle with this. You don't have to. Okay, so she kind of, whoop. Yeah, you went one too short. Just erase, you're good. I probably would have messed it up anyway, so. Just go, okay, no? Okay, go ahead. She was right there. She just had to go one further, that was all. So she copied the 2. Your arm was on the thing too, that's all. There it is. Okay. So we'll get rid of the extra marks there. So is it 3 by 1 by 2? And should this one over here be 2 then? Yeah. Should this one up top be 3 right here? Yeah. 3. Yeah. And so that's to help you draw it if you really struggle. What I'm going to do in the next couple examples is to show you how to do it if you don't want to use the dot paper. It's a mix of students that want it and a mix that don't. Okay. So any questions on that one? All right. So rectangular solid that is 5 units high, 6 units long, and 3 units wide. Excuse me. So once again, I'll just start with this. Normally what I'll do is I'll say, okay, when I do it this way, I do it more of a rectangular method. I just make sure they kind of match up themselves. Again, the square dot paper really not going to be very helpful. So I'm going to say that's 5 units high. Have we got that? And then I like to do the biggest measurements first, right up front. So 6, right? Do you agree 5 by 6? I just made it 2-dimensional. And what I'll do is I'll do the angled parts myself. That's where the dot paper is helpful. But the dot paper won't let you do this. Make it nice and in front of you like this. And so that's where you have to find out what's going to be. So I did 5, I did 6. Which is the one I haven't done? 3. So what I'll do, everybody ready? You just have to pick whichever angle you, again, I go up and to the right. That's just how I do it. You have to pick whichever way you want to go and make it a certain length. Do the same angle, same length. Same angle, same length. And get it close. Are you going to be perfect? No. Yes. You could, whichever direction you want to go. If you want to go down and to the right or down and to the left, it doesn't matter. It's whichever one you're most comfortable with. And then all you have to do is finish it off. And where would I put the 3 then? Where can I possibly put that number? Yeah, on the lines I kind of just drew, right? There's 3. Because what would this line be right there? I just put the dot. How much would that be? 5. How about this one back here? How much is that? 6. How about this one? 6. How about, we'll make one a little harder. How about that one? 3. Yeah. And what's the only one left? This one here, which would be? Do you notice, do I put the little dash lines behind it to show the ones I'm missing? No. Can you do that? Sure. If you feel comfortable, you can go ahead and do that. I normally don't because all I want to be able to see is the faces. And let's face it, if I'm talking about that face right there, there's one in the front and there's one in the... So how many of these do I really have? I really have 2 of them. Same thing here. There's one on the right and there's one on the left. This would be top and bottom. So it works out. So why don't you take a second and try the last one on your own.